Everyone, we're honored to have Wendy Ju, Associate Professor at Cornell Tech and board member of the Open Source Hardware Association, presenting a demo on using digital twins to support public interaction and mobility research at scale, in scenarios such as urban driving, pedestrian traffic, and even emergency flooding scenarios. Wendy, the floor is yours.
Thank you so much. As Alex mentioned, I'm an associate professor in information science at Cornell Tech, which is in New York City. And actually, in the background of this opening slide, I actually can show you. I'm actually in one of the buildings that's modeled here. So this is Cornell Tech is on Roosevelt Island in the East River in New York City, and then the Queensboro Bridge runs through the island. And I'm actually in this high rise right now. What I want to talk to you about is this idea of open city, which is a mix of work that's being done in the digital twin space with the possibility of having immersive, virtual, and mixed reality models so that we can actually understand how people are going to behave in the city at large. And this is really useful to understand how a variety of urban services or mobility research will actually take place when we actually try to use it with people. So I'm just going to say a little bit about urban digital twins, and I feel like this might be something that you've been hearing a lot about over today. I really like this slide from CNN where they basically talk about how digital twins are created and how there's many layers that basically form the data model of the city that really helps people who are professionals make urban planning scenarios. So this is basically not only the physical layer and the information about the building's infrastructure, but also models of things like the transportation, the trucks, cars, ships, what have you, but also the information layer about what's going on in the city. And this is information about when you have different levels of traffic, different kinds of pollution, different temperature, going on. And then the digital twin basically does something to bring it all together. So the things where, for example, the mobility would affect the occupancy in other places like that, that's something you could actually get from having all these pools, streams of data pulled together. One of the things that I've been working on in this space of of digital twins is just getting massive urban data sets and thinking about how to draw meaning from them that actually informs things that people want to care about. I started doing this during the COVID-19 pandemic. One of the things that was a concern was in New York City was just where people were out and where they weren't, and where we actually want people to be. And so one of the things that we could do is actually use some public data sets like the Mapillary data set, which is captures of kind of public activity, but streetscape activity taken from individuals' cars, contributed to a big shared network that makes it possible to go and look and see where people are gathering, what people are doing. There's actually also a professional version of this through a company called Nexar. I'm sure there are also companies that makes network dash cam. So based on the location you are in the city, you can capture information that shows where people are out, whether people are wearing masks, whether people are standing in line. And then we can actually, because both the Mapillary and the Nexar type data sets are really sporadic, it was important when we were trying to look at what sorts of activity was going on in the city to put that against the ground truth of something where you have an always on camera. So New York City Department of Transportation has these different traffic cameras deployed mostly in Manhattan, some other high traffic areas in Brooklyn and Queens. We could actually see when we see a certain number of cars go by, for example, in the Nexar data set, how many of the actual cars that go by are we really sampling there? Having these large, data sets of images makes it possible to find out what's going on throughout the whole city in a way that's really difficult as individuals to do. One thing that we did after the fact, when we had this data set and we're no longer thinking primarily about social distancing for the COVID-19 pandemic, was to ask questions for example, what is the difference in police deployments in New York City? Are there more police in places where it's really high income, or are they evenly distributed? And the suspicion has always been that there's maybe more deployment around commercial areas and less deployment around residential areas. And one of the things that we were able to do is take these large data sets of images and actually train a classifier to recognize police cars in specific, and at least to say, using the police car, presence as a proxy, like where we actually see those cars distributed throughout like New York's 5 different boroughs. And I should mention this is work that was led by my PhD student, Matt Franchi, and done in collaboration with Emma Pearson, who's a fellow faculty member here at Cornell Tech. And based on the analysis that we did of those images, we were able to show for the period of time that we had data, like these like really strong differences in police deployment. For example, like the thing I said earlier, which is like, are there more police deployed in commercial districts? Turns out to be very much the case. You can actually see it's like, like over here in the red, there's just like a much more commercial deployment of police activity than manufacturing or residential. Also, police are overwhelmingly deployed to the lowest income residential areas compared to the, second lowest and second highest and highest quartile, which means those people are more likely to be caught doing something because the police are more likely to be in their environment. And also that there is a higher distribution of people, police in residential zones, which are primarily Black and Hispanic, and much less actually, for example, for Asian neighborhoods. And this map kind of shows that difference in deployment. So having a data set like this makes it possible to start having conversations with the government, with one another about what kinds of distributions we actually think are ideal. And it makes it possible to take these things that you get a feeling for, you see a cop, it seems like there's a lot of cops, like and actually like not just generalized from anecdote, but actually kind of look at that a little bit more systematically. So the possibility is to have urban digital twins that help like gather all this kind of data and facilitate these sorts of conversations. But what I really want to focus on is this, what I think is the future, a little bit less about using urban digital twins and the data that gets collected for understanding the current state of things, and thinking a little bit more about perspective planning, what we would like to have happen. So I think having the data, having the retrospective look helps to support conversations. But you can see here, these are 4 cities that have urban digital twins, and the way that these urban digital twins are always represented is having some sort of like, virtual reality model of the city. And this is actually really different from what an actual urban digital twin is today. And so I've been proposing this idea, what we call open city, which is not only having the digital twin, which is largely a data model, but then thinking about how that gets translated into something that's more immersive and simulated. So many people here, maybe including myself, have played SimCity. Like you basically can set up buildings, go through neighborhoods, imagine your own life, there. So the vision for Open City is to couple these urban digital twins, which, like I say, are largely about data, with interaction engines, like things that we are used to from gaming, so we can create these immersive virtual worlds or models of real world cities. And the goal is to enable people to experience a wide variety of simulated research environments, both helping people reflect on things that are happening that they might not had first-person experience with, but also for us to put in things that might happen and then have discussions about what we would like to happen. And we think that this will help researchers study how people are going to respond to things like urban driving, pedestrian traffic, robot delivery, or other emergency flood and disaster scenarios. Like, these are things that we have difficulty talking about and getting everyone on the same page about, and we could do a better job of using some of the technology that is at hand. So I'm going to show this project. It was led by my postdoc, Sharon Yabo Aylan, and a large team of people. I think this is pretty amazing. And this is research that was done on Roosevelt Island. Roosevelt Island has its own bus system, the RIAC red bus. And we actually had something where we gave people a VR tour on the bus to help them think about climate change and flooding.
Extended realities, XR, has been proven as a powerful tool to engage communities in an embodied and intuitive way. Building on what we have developed in the CXR system, a communal extended reality system for situated on-road immersive experiences. In simple words, the CXR system enables a group of people to use virtual reality headsets inside a moving vehicle and watch the exact same route in a virtual digital twin. The virtual world is geolocated and progresses in sync with the physical world. In our case, we used it to simulate flood and climate change scenarios, but we believe it could have many other implications. In this paper, we describe our advances in modeling of the digital twin and our technical development and setup of the CXR system on a moving bus. The Roosevelt Island digital twin is created based on the open data of New York City Department of City Planning with Google Earth as a reference. We digitally modeled the educational institutions, religious complexes, retail corridor, and other essential buildings along the route, and populated the digital twin with key objects including stop signs, light poles, fire hydrants, and trash cans. With a dynamic environment system, water level animations, fish flocking, and floating objects, we were able to visually narrate 9 climate change scenarios immersively to the participants. From a bus simulator in our lab to a series of pilot rides on the actual bus, we iterated on the software and hardware of the CXR system. The full-scale bus simulator was used to test out the layout of the seats, the setup of the equipment, and the coordination among the soundtrack, the VR headsets, and the projector. Through test rides, we further determined the scale and position of the projection screen, developed the bus rover, a wheeled cart with equipment integration for efficient deployment, and iterated on the synchronization between the virtual scene and the movement of the bus. We define our project as communal XR system because it brings people together in a shared social experience and combines several shared immersive modalities such as a mutual soundtrack, a common vehicle, and a collective hybrid environment. To synchronize the panoramic scene with real-time geolocation, we developed an Android phone-based GPS app that is operated by a researcher. It reads the GPS coordinates from the phone and publishes the data to a central server using the MQTT protocol. The VR headsets would receive the data and synchronize their playback speed accordingly. Our system also incorporates a projection screen that gives participants the opportunity to lower their level of immersion when they encounter motion sickness.
So I will say, this is funny, this like YouTube page. So before I got to the nuts, I mean, I think that project, I should say, we actually did a study where we had like over 70 people from Roosevelt Island come in and like ride the bus and then like talk to them. We had pre and post focus groups. We talked to them both about flooding situations that happen like on this island and climate change. And what we found was that basically having that shared experience helped move people from conversations where they were talking very generically about wanting to like help the environment, get people to recycle, you know, like drive less, to like thinking in much more granular tactical terms about like where are the places there might be flooding, where are sensitive populations on the island, what can we do, you know, to make it so that if we have flooding, we like actually know how to respond as a community to those things. And that's like a really powerful thing to have from like one shared experience. So I think that's something that we think that these like new ideas of open cities could be supportive for. One really great thing about the way that this is set up is that we have this digital model, we can make our own course, but people who live in other places can take the same technology we have underneath, the interaction engine, but then make scenarios and host discussions that are pertinent to their own local community. So I think there's some opportunity by having open models and basically sharing these interaction engines that we could actually help facilitate these kinds of conversations in lots of places. The next thing I'm going to show is something that's not yet published work. It's a system called Portobello, which makes it so we can actually have a mix between what's going on in the real world and then what we can simulate in the environment. And that makes it possible to see how people are going to respond to things that we would introduce into normal environment, and then you know, run different kinds of experiments to understand how people feel about it.
We have designed an on-road driving simulation infrastructure named Portobello that allows drivers or passengers in cars wearing mixed reality headsets to see virtual objects overlaid on top of their real-world view. To date, simulators with this capability have been unable to replicate the types of driving studies typically performed in lab simulators. Portobello makes it possible to port studies developed for in-lab simulators to be run on-road, a functionality that we call platform portability. To achieve platform portability, we have applied sensing and localization technologies from robotics and autonomous vehicle research to stage virtual events in the world frame. A LiDAR and IMU are used to localize the vehicle in the world frame and infrared tracking is used to localize the participant's head movement within the vehicle. To validate our system, we ran the same autonomous vehicle interaction study in both our on-road driving simulator and an in-lab driving simulator, an approach we call twinning of studies. We were able to port our study design, which involved having participants assist an autonomous vehicle in determining when it was safe or not safe to drive when virtual pedestrians were present. With our system, people are able to see virtual avatars exactly where they were programmed in their corresponding location in the real world. The workflow to make platform-portable study designs requires mapping of the real-world course environment. We first scan the test area and obtain a high-resolution point cloud map of the environment. The point cloud is then imported into Unity. The in-lab simulation environment can then be built to be a digital twin of the real-world course, and study events can be staged on the map. At runtime, we use our real-time navigation system to locate the vehicle position and update the headset camera location in Unity.
So I think some of the things that we are motivated by in this line of research are thinking about like other people. A lot of the things that I do for driving simulation research or, immersive interaction research is pretty expensive. It uses a lot of space. We're using fancy equipment. And we spend a lot of money like on personnel, basically developing these scenarios. But what I would really love is to take the things that we develop and have a lot of other people get to use them. So the payoff is good. One of the things I really like about developing things in VR is that as these headsets that people use for gaming become less expensive, even though it was expensive for us to develop the environments, the simulations, it can be really, I think, with the coming generations of like headsets, easy or low cost for people to deploy studies using them. I also think that when we get to the point that like different cities have their own digital twins, but we can share interaction engines, or you might share the model that you have your city with people who are doing totally different kinds of studies, we can actually increase the payoff for different sorts of development efforts. And one of the things that's really interesting is a lot of the studies that we do right now, we basically make the assumption that people everywhere are the same and we want them to respond in the same way. We call it generalizability, but we know when it comes to cities that every single city is really unique and there's a lot of conditions on the ground that we have to understand going in. One of the things these kinds of simulation studies, particularly the ones that do a good job mirroring or mixing real world city information with the virtual, it makes it easier for us to understand the ways that the particularities of every city will influence the way that people will behave. And I think that's actually something that we should want as scientists, to understand the way that all these little things that matter, how they matter, and what we can expect based on that. One of the things that is a little, I think people often look at the stuff that we're doing on the urban sensing side and they feel a little iffy because there's just like a lot of data about people in public places and they're not anonymized. So it could accidentally catch somebody doing something that they didn't want their boss to know about. One of the things that's nice about the VR data is that you can actually take it and share it. And the data about the people are anonymized in ways that make it easier to collect and share participant data. It's real data about how people really will behave, but it's not videos of people in public places and actual points in time. And so in some ways, having data sets that are a little bit immunized from the problems of naturalistic data could be useful. And then finally, having large sets of data collected in different locations then improves the generalizability of findings or helps us to understand regional issues in a way that I think we have difficulty doing now. So with that, I'm going to wrap up. I understand there's not a Q&A session, but if you have questions, please do feel to email me at wendyju@cornell.edu.